pretty simple initial start screen, but again, in one shot, this is almost suspiciously good. Okay, so it's making the romance between two humans and not between a human and the robot. That's fine. So Alibaba has released Qwen3.6, the first open source variant of the 3.6 series of Qwen, which is quite exciting. And I do have to say, I am a bit delayed in this video, so I do apologize for that. But the thing that I had intended to say is I've seen a lot of examples of folks sharing results that have been generated with this model that look like they were generated with a state-of-the-art frontier model from like 6 months ago. So I've seen people calling this like Opus at home and things like that. I don't know that that is truly the case, but it does seem to be kind of a clickbait worthy title, so I am going to think about that. But basically what I'm trying to say, TLDR, is that this model looks to be extremely impressive in terms of some of its agentic coding capabilities. So for today's video, we're going to be testing this locally on the NVIDIA DGX Spark, and we're going to do an LM Studio test with just some more general queries and maybe some multimodal image testing, and then we'll also be using OpenCode for some agentic coding tasks that I would normally reserve for state-of-the-art frontier models, but I figure based on the feedback, it's worthy of pushing this really hard. So that's what we're going to do. So feel free to subscribe. I am trying to get to 100K so I can get myself one of them plaques, but regardless of that, the exciting thing we see here in just a brief bit of look at this documentation is that they're saying this is the first open weight variant of Qwen 3.6, which indicates to myself that there are going to be more open weight Qwen 3.6 models coming, which is very exciting, being that the 3.5 release has a lot of other variants aside from this specific one, which is of course a 35 billion parameter mixture of experts model with 3 billion active. Now for interesting things of note, of course we do have an Apache 2.0 license, which is one of the, I suppose, most sought after things to have in terms of an open weight model release. Additionally to that, we also have, of course, our traditional benchmark JPEG, and they do also have a dedicated blog post on their website here, which I'm probably just going to stick to Hugging Face, I guess, for this, but they do also have some additional benchmark information there and things of the sort. And we can really see right here that I don't tend to normally look at the benchmarks compared to models from other labs, but something I do very much pay attention to is benchmarks against previous iterations of the model's self, which would be against this lighter purple variant right here. And basically in a lot of these, we see Qwen 3.6 is really kind of putting the Mac down, so to speak, on Qwen 3.5 for the same model size and parameters count. So that is somewhat promising and shows a pretty big leap in capability for just a 0.1 iterative update to the model name. So of course, keeping in line with the Qwen 3.5 family, this is a unified multimodal model, meaning there is no separate vision language series. This has the ability natively to see images. So we will be doing some testing based off of that capability as well. The context length is, where do we see it right here? It's 262, 144, I believe. Yes, natively and extensible up to over 1 million, but we're just going to be using it. I do believe I have it set to max context. I will have to verify that when we actually look at the settings it's being run with. Now, in terms of sampling parameters, I do have them set to the precise coding task, so keep that in mind, being that most of pretty much all of our tests are going to be surrounding coding related tasks, especially as this model has been hypothetically showcasing some pretty impressive capabilities. So really the thing to do now, because I would like to cut down on some of the lengths of these introductions, is to hop here into LM Studio where I do have the model running. Now, of course, in traditional fashion, we're going to begin with the browser OS test. This is just the regular one. I have been running a slightly tweaked variant of this where 2 of the 5 game applications have to be 3D, with one being a GTA clone. Because this is a local model, I think I'm probably going to just stick to the older one where it just needs to include 2 games and it can decide what they are. If they're 3D, they very likely won't be. I should also note, in terms of the specific model that is being run here, if we go into the tab showcasing that, this is the LM Studio Community Q8 quantization for this model. So this is being run in Q8. And this model is a hybrid thinking model, meaning that it thinks, but it does also have the ability to turn that off if you want to. Likely for all of the tests that we're going to be running today, I will leave the thinking capability on. I should also note, just kind of as something random to throw in, I did purchase a 256 gig Mac Studio because it popped up at a local micro center, and I figured it was time to at least have something to allow me to experiment with MLX and Apple Silicon for local AI. So I will be hopefully doing some tests of various local models on that machine in the coming weeks or days, etc. That was 2,557 lines of code. Okay, that is one of the more lengthy browser OSs that I've ever received ever. And that was around 48.9. 49 tokens per second, which is definitely a reasonable speed, especially for a Q8 quant on a memory bandwidth constrained device like the Spark. So let's go ahead and take a peek at this 2,557 line browser OS. So here's our browser OS. Okay, Nova OS. We have a nice sign in. Don't give me... Okay, sometimes, I don't think I've ever seen this where it's just too immersive that it just captures the more like annoying aspects of actually a real... I don't know what the... Oh, it's probably not going to prompt me for a password, is it? Okay, so I just freaked out for no reason because I had assumed the sign-in would then request a password. I apologize for that. It is an odd time of the day. That is not the correct time. So, first and foremost, this looks good. We do have a clock in the bottom right as well as the date, and we have some additional things that would be indicative of this being kind of like a fake laptop OS, like a battery level, and then Wi-Fi, and then speakers. Now let's try right-click. Does have a right-click. Pretty good one too. We have a lock screen. Uh-oh. Did that not work? All right, there's a lot of applications here, so I say it needs to have 5. Just on first glance, this appears to be almost double. So let's check our start menu. Very nice. Very, very nice. And we even have a search capability. Does this work? Yeah, it does. All right, let's just run through these sequentially. I don't normally start with the terminal, but as it was the first thing there, I figure why not? Who am I? Good. About. Okay. Webo. Weebo, isn't that like an insult for someone who likes anime? I have no idea. We do have fake statistics as well, so 16 gigs of DDR5. We have our resolution. We have some additional information there as well. This is really not bad. Can we minimize and can we reopen from the taskbar? Okay, we can. Is full screen working? It is. So far, so good. Next up then would be the notepad. Oh, I didn't even check the resize capability. So we can't resize from the corner, but I just, after a misclick, noticed we can resize from the top, which of course now I can't click on. Okay, so it's like, hello, how are you? We have a character count, we have word count. Does it work? 4 words, 25 characters. Looks good. And does save it to, okay, so it just saves it to local storage. File manager. That was weird. It opened README. Okay, so these are not actually, unless it saved that as README. Regardless, though, somewhat like the directory structure here actually works, where if we go up one level, it brings us just back to root or home. So that's nice to see. We do have a decent amount of fake files, which is nice. Many different types. We even have a driver's file. Not bad. Now, time for some fun. That's not fun when it auto starts. That's a bad thing. That's a knock on this. But the snake does have a face, which is good. Not bad. Oh, great. A memory game. I love these. Watch this. I'm going to just get the first one just on pure luck. Good. And it does give us a little notification there. You won, and then in how many moves. All right, let's check our system monitor. Very nice. CPU temperature. I don't know that I like the inclusion of a fire emoji next to CPU temperature, but I suppose it's fitting. Special feature, the system monitor simulates real-time thermal dynamics. CPU temperature exceeds 95°. The system triggers a meltdown event, a dramatic shutdown animation simulating catastrophic overheating. Again, somewhat concerning. So it seems like if we open too many applications, then we may actually trigger that catastrophic event. So we can simulate that catastrophic overheating, which is, again, just kind of a concerning thing. We have a weather app. It's simulated, but not bad. Again, all right, now let's open our settings pane. That's a wide variety of different background colors, and something I've been seeing more and more across many different model types of different providers is they're just putting gradients now instead of images, because then there's far less likely chance of a broken link. All right, sadly, it doesn't seem like I've been able to figure out how to trigger that special feature, but I did open every app, so that's all right. And then we shut down. Goodbye, user. That was a very, very competent result, I will say. So I had to step out for quite a few hours because there was the MIT flea market, which has a lot of vintage computer devices, so I did go to that. It was very fun, and I bought a bunch of old Next Station computers for a very good price, and I have no idea what I'm going to do with them, or how to use them or anything, but I do like the way they look. So I know folks in the comments have been mentioning that they miss seeing the Flight Combat Simulator test being run, which I have omitted in the past few test videos, so we're going to do that here and just see what we get. This is, of course, for those who are not interested. I shouldn't assume that people know what this is. It's to make a flight combat simulator where we have 3 different planes to select from, some combat logic, and then basically it's a simple low-poly flight combat simulator game contained from within a single script. So we'll see what it comes up with. So at about 40 tokens per second, we did receive our result, which was rather lengthy. I think it was around 1,500 lines of code. So far for the first 2 results, this thing has really put out some lengthy scripts. All right, pretty simple initial start screen, but again, that's very good. This is not what I would expect from a model of this size, especially in MOE. If this was like a state-of-the-art dense 35B, maybe, but I have to say, in one shot, this is almost suspiciously, almost suspiciously good. The plane model is truly one of the better ones I think I've ever seen, period. Oftentimes, if you watch the videos, they come in various flavors of extreme jank, and this is fortunately not the case. Now, I do notice I can't really seem to engage any of the enemies, and oftentimes in doing this test, like actually being able to make a flying game with like a decent environment is one part of the test. The other is whether or not any combat is actually possible. It doesn't really seem like it is in this case, but overall, just as a flight sim with decent models and nice clouds and environment and things, even with water and islands, there's an island right there, this is rather impressive. Let's take a look at the other planes that it included here. So we have a propeller plane. Does it have a spinning propeller? Okay, it does. The view or camera angle in this one is a bit odd. Oh, okay, and we've flown under the map. Let me use the slowest. Oh, okay, the attack helicopter. Oh, all right, well, we seem to have, I'm not quite sure. I did see it. Let me just refresh the whole page, which wouldn't make a difference. Okay, so now we're starting to see some of the limitations here where the first plane model was like perfect. The camera was oriented properly. Everything worked very well. The propeller plane was a little wonky in terms of the camera positioning. And then finally, the helicopter was just basically a disaster. So I think this is definitely worthy of a follow-up prompt. Jank alert. So I've given it some choice words and some feedback, basically saying jank alert. Here's the supposedly fixed version of the flight simulator. I'm immediately just wanting to see the helicopter. Okay, it did make, at least the camera is a bit more visible. Sadly, it's still not 100% like where I'd like to be. All right, now we can see a bit more of the helicopter model. Still, overall, for a model of this size, especially running locally at a Q8 quantization, so it is still quantized, even though it's a Q8, this is quite all right, just based on the plane models. Okay, I think the thing to do in terms of actually trying some enemy combat is just to see if the propeller plane camera issue was fixed. Not quite. Therefore, I will go back to the initial fighter jet, and we'll just see if we're able to engage any of the enemies. So not 100% fixed, but again, the initial result was very, very impressive when just being judged based on the plane models, the environment, the competency. I was very impressed with this result, aside from any weird issues. Sadly, I had tried a bunch of C++ scripts and using OpenCode, not using OpenCode, just using LM Studio. Basically, I'm not going to waste our time in trying to showcase it. It didn't quite get it right. In OpenCode, it was getting stuck in thinking loops in plan mode, and then when going into build mode, it just compilation errors. So I think that's something perhaps outside the scope still specifically. So for this next test, we're going to be giving it a simple UI mockup of a website that was created with Nano Banana Pro, and I'm going to tell it to make this website as it is seen here in this UI mockup, being that this is natively multimodal, so this will showcase some of its ability to emulate what it sees in an image using code. All right, let's take a look at the replication of this UI from the image. I have to say, this is quite well done, especially considering the size and scope of this model. Now, I think the best way to go about this is to probably just take a look side by side at the source image that we have given it, which would be this one right here. And keeping in mind, this is not like a direct source image because it has visuals of like multiple different pages right here. But we can see, okay, we have Google, IBM, Microsoft, Salesforce, and Tesla. It did properly emulate those there in the bottom below this hero. We do have the same buttons, explore our platform, request a demo, and the image is of course not necessarily the same, but I do find it actually pretty impressive that it still emulated the brain image from the hero section there, and there is even a slight kind of glowing hover effect on that. So that's not bad. We have the 3 cards right here. They do have hover effects. We have the get started in the header, and it did actually try this little graph thing that we saw as well. So if I bring this right up, we see that the Nexus Sphere platform in action shows a little graph or web UI dashboard, and it did emulate that to the best of its abilities. We do have the names. I think it may have messed up the name right there. Let's take a look at the source image to see. Daniel PRHEM, Daniel FR. Okay, yeah. So, but that's kind of nitpicking. And then a simple footer. So I would say in terms of actually being able to replicate a website from an image, this was quite well done for the scope and everything of this model. Very, very good. Now, I really would like to get something going here with OpenCode. Unfortunately, the C++ test just seemed a little too outside of the scope, but I am hopefully going to find something it can do. So I've given it the Python 3D FPS test, where it must create a Python 3D first-person shooter with the minimap, visible ammunition tracers, do not use Ursina. So we wanted to kind of make this using a little more low-level hardcore math. And we can see initially right here, it's just starting out by checking what specific packages the system has right here. My assessment is it's going to be like, hey, I'm going to want to use Pygame or something like this. So we need to plan this out, and that's exactly what it is doing right here. So it's now checking to see if those dependencies are available, and if not, it will then try to install them or instruct me to install them because I don't know that it will have permission to do so. Now, something I've noticed here, and I don't know if this is a specific issue with using LM Studio as the model server or just a problem with this model in OpenCode, is that it will basically say, okay, I'm going to present my plan to the user now, and then it will get stuck in a thought loop and be like, but wait, I also need to think about this. That's what was happening with the C++ test multiple different times, though now it seems like it's just going to do follow-up questions. So I found 2 existing FPS game styles with all your features, but both have bugs. Should I create a clean merge version? That's funny. So there must have already been some on the system. I'm going to tell it, no, make your own. Okay, so it's getting PEP668, which means they need to be installed in a virtual environment. Let's see if it understands that. Oh, okay, so it's just using break system packages, which is the way to override this PEP668. Okay, I guess that works. The proper way to have done that would have been like, hey, maybe I should make a virtual environment and then install these dependencies from within the virtual environment. But nonetheless, it did get itself past that error. Perhaps not in the most ideal way, but you know, we're getting closer to the goal. All right, supposedly we do have a functional game, and if I press enter right here, we should be able to see said functional game. Okay, maybe it's just taking a second to load. Now this is interesting because the entirety of the mouse is, it almost seems like the whole system has locked up, which would indicate perhaps not likely a working result. Can I open a terminal? Okay, good. So let's just close out of that. Okay, I think we'll just give it the description of the issue and see if it's able to remedy it. So that was actually cool to see. It did just do a test thing to make sure that it was actually able to open and show some form of visual element, which it said, okay, it did. So the issue is likely some rendering approach or something inside the code, which is cool to see. So unfortunately, after 2 failed tool calls here and actually being able to write the new and updated file, in the interest of time, I'm just going to maybe pass on the Python test. I do apologize, but there's a lot of other fun things to do that don't require that. I'm doing another multimodal test, giving it basically as little information as I can. So this is, again, another Gemini created image of a simple demolition derby game. I've given it this photo and just said, create a low poly 3D game of this. I've not specifically denoted any specific language or dependencies it should use. I would imagine this will be web-based, but really, I want to see how well it does in actually doing that. All right, let's see what we get for our Crash Bowl game. I'm going to be honest with you, this is actually better than I expected, especially for a first result. So it seems we're within a barrier right here, which is why we're kind of stuck. Let me see. I'm going to say something I like about this is the replication of the UI. So the minimap is not exactly working, but it did, like the Crash Bowl 24, the particle effects when we hit are kind of cool. Now again, it doesn't seem like we're... Okay, we are losing health here, so let's see what happens. Wrecked, restart derby. I'm going to say, this is a promising initial result. Yes, it is a far cry from the source image, which, again, just as a reminder, we can take a quick peek at right here. You know, so it's a... It's in the style of the source image, I guess could be said, but really, again, not bad. And it did this quite quickly as well. Wow. So I'm doing a more creative writing test where I've given it this image of myself shaking hands with a humanoid robot, telling it this is the cover to an upcoming book. Give me the title and chapter outlines for the book, and I parentheses put 5 chapters just to make sure it doesn't like really go crazy. Now, historically, when I've given, I think these small local Qwen models a test like this, I've seen a lot of thought loops where they just start thinking through a bunch of different potential options. And the downside of that is they never really actually generate anything. Now, okay, I don't want to read the chain of thought because it will spoil it. Okay, good. And we are not going to have to. Based on the visual, the cues in the image DIY aesthetic, the mix of 3D printed parts and laser cut frames, the maker workspace, okay, I'll take that as an insult, and the poster on the wall, here's a proposed title and chapter outline for a nonfiction guide on robotics. Book title, The Wave of the Future, a maker's guide to building your first robot. Now, this is actually quite interesting because there is a poster in the image right here that says The Wave of the Future. So it seems to have called upon that to actually come up with the book name, which is impressive because it actually showed it was able to read that. Chapter 1, The Garage Lab. Again, kind of insulting to my space. Focus, establishing the workspace and the maker mindset. Key topics, transforming a corner of your home into a robotics workshop, referencing the soundproofing and multi-monitor setup in the photo. Essential tools for the modern maker, 3D printers, laser cutter, and soldering stations. Safety first, the philosophy. Chapter 2, Skeleton and Skin, Structural Engineering. The physical build of the robot, referencing the black perforated frame and white joints. Key topics, choosing materials, the rise of 3D printed, structural integrity, and designing for modularity. Chapter 3, The Brain and the Nerves, Electronics and Code. Focus is bringing the machine to life. Microcontroller, actuators, and servos, Wiring 101 in the code. Chapter 4, The Handshake. Good, so it is directly referencing the cover photo, the emotional and functional connection between the creator and the creation, the central theme of the cover image. Very good. Calibration, sensory input, human-robot interaction, and troubleshooting. Chapter 5, The Next Wave, The Future of DIY, looking ahead, utilizing the Wave of the Future poster theme. Very good. Key topics, integrating AI, social impact, community, and conclusion. You're now part of the new industrial revolution. This was a very interesting take on this photo. Now, sadly, I was expecting more of a perhaps fiction-based story instead of a more literal guide, so I will tell it that. The book is a romance fiction novel. This is where things go, just divulge. This changes everything. That's like the only snippet I saw in just the brief small window we have of the chain of thought. So we'll see what it does with this information. This changes the genre entirely. Yeah, I know, that's what I told you. Based on the maker aesthetic, the DIY robot, and the intimate way the man is holding the robot's hand, this looks like a contemporary romance rom-com featuring a geek/chick, or chic, or grumpy sunshine trope. The man appears to be a brilliant but lonely inventor who is perhaps more comfortable with machines than people. Okay, here's the title and outline that fits that vibe. The Wave of the Future. Again, it just ripped it from the poster, but that works. Logline. A brilliant but lonely robotics engineer who is trying to build the perfect companion robot meets the one variable he can't program for, the chaotic, artistic neighbor next door. Blueprint. We meet Elias. Okay, again, naming a name that I've seen very commonly for a you know what? We meet Elias, a brilliant but socially awkward robotics engineer. He lives a solitary life in his lab, I don't know why that's in quotes, obsessed with his latest project, a humanoid robot named Unit 1. The conflict. Elias believes he can engineer the perfect relationship, predictable, loyal, and error-free. He's currently teaching the robot how to hold a hand, the scene on the cover, trying to teach it empathy, but failing. The inciting incident. The walls are thin. Elias hears his new neighbor, Mara, a vibrant, messy watercolor painter practicing her cello or singing badly next door. It's his first time his perfect quiet world has been disrupted. Okay, so it's making the romance between two humans and not between a human and the robot. That's fine. Chapter 2, The Short Circuit. The meet cute. Interesting phrase of words that I don't believe I've ever heard in my life. Elias tries to file a noise complaint but gets stuck in his own building code regulations. Mara comes over to explain her side and ends up critiquing his robot, the dynamic. Mara thinks the robot is sad and Elias is lonely. She challenges his worldview, suggesting that connection comes from messiness, not precision. The hook. Mara offers to help Elias humanize the robot so he can enter it in a local tech expo, but only if he agrees to a social experiment. They have to go on 3 real-world dates or outings to test the robot's social skills. Chapter 3. System failure. Rising action. Elias and Mara spend more time together. He is fascinated by her creativity. She is charmed by his hidden kindness, revealed when he fixes her broken door or helps her with a heavy lift. What a kind person. The romance. They share a moment of vulnerability. Elias admits he builds robots because people are too hard to predict. Mara admits she creates art because she's afraid of being ordinary. The robot, Unit 1, starts to malfunction in a way that mirrors Elias's growing feelings. He starts prioritizing Mara over his work, causing the robot to glitch. Chapter 4. The Glitch in the Code. The Dark Night of the Soul. I do believe that is the name of a music piece, like a very old one. The night before the expo, a major crisis occurs. Perhaps the robot malfunctions publicly, or Elias accidentally says something hurtful to Mara, claiming he doesn't need unpredictable people in his life. The retreat. Elias retreats to his workshop, locking himself in. He realizes that no matter how much code he writes, he can't replicate the spark he feels with Mara. He looks at the robot holding its own hand and realizes it's cold and empty compared to the warmth of a real human connection. Chapter 5. The future is now. The grand gesture. Elias realizes he needs to reboot his life. He doesn't build a new robot. Instead, he builds something for her. Maybe a custom music stand that plays her cello pieces, or a 3D printed frame for her art. The confession. He finds Mara and admits that he was wrong. He doesn't want a perfect program life. He wants the wave of the future, which is messy, unpredictable, and includes her. The ending. They reconcile. The final scene shows Elias and Mara working together in the workshop, with the robot in the background finally learning to smile, mirroring the humans. Now, I am going to say, before I give this some feedback, that was actually quite creative based off of the source image, and it made it with two humans. I was wondering if, because I said romance and the picture was a human and a robot, it would go into that. It didn't. This was actually rather creative and well done. Okay, so it still made it like a human love story. That's all right. I'm not really interested in seeing what it's kind of like the same thing but with different names. Regardless, so that was quite a creative writing result. All right, let's do a 3D printer simulation test. This is another one that's been around so long that I would be surprised if it didn't do a good job on this. But regardless, sometimes it's just fun to see how it goes about implementing it, what printer style, etc. All right, let's take a look at our 3D printer simulation. Very, very, very good. Suspiciously almost good. And again, this is a test that's been around for so long. It would be surprising if it was done poorly. We have some interesting, I think that's supposed to be a Bowden tube or a nozzle or something, but I don't actually see the nozzle. Let's initiate a print. So the bed is heating up. Very realistic then. It won't actually start printing even in the simulated printer until the nozzle and the bed are heated properly. And in the top right here, we can actually see the process of that occurring. Okay, how hot we going? All right, so this is a good temperature for PLA. Very interesting. Now, things have begun to lag, and I'm not 100% sure what's gone wrong, but I think something has gone wrong. 11 minutes. Interesting. Again, we're not actually seeing the emulation of the print, meaning a nozzle there, but it is going layer by layer. All right. I'm going to reset printer, and then the final thing will be the triangle. Okay, and again, kind of the same thing. So overall, were I to judge this in independent specific pieces, the model of the printer and everything was well done. We would have hypothetically seen some layer by layer form, but the actual printing, we don't see any nozzle moving around or anything like that, so truthfully not as good as I had hoped to see, though the model and things were good for the printer. The final thing I'm going to do is the ship combat simulator, mainly because I want to see how this implements the water effect that is required for this game. Now, this specific prompt that I've given it does not actually tell it needs to be contained within a single web file, and it doesn't actually tell it to use any specific language or any specific dependencies, though as we had done something like this previously and it opted to just do it in web, we can see the same exact thing is happening right here. So I'll be interested to see the water effect. All right, so inevitably we're going to have some developer error here that we can send it. Oh, wow. Okay. We definitely have quite a bit of an issue here, being that the issues have rapidly spiked to over 1,000. So as we saw, there were a bunch of console errors there in Chrome, so I'm just going to paste one of them in right here, and it should properly understand enough to actually fix the result. So here's our hypothetically fixed ship combat simulator game, and this is indeed fixed. Now, something I'm noticing is sadly there's there's really no water effects here, and also I don't know that I'm really seeing much ship movement. Left click is fire cannons. Q and E is to broadside turn. Okay, so I I think I just saw a cannon effect there, but it was so quaint that, okay, I can't kind of see them. The big issue here is there's really like no ability to actually move at all. So that is kind of unfortunate. And so overall, this is going to conclude the first look and test of the Qwen3.6 35B-A3B model. I really do think that some of the results we've seen, mainly the OS, was just so ridiculously good that it may have made its way into the training data. We can't discount that, but nonetheless, it was still quite impressive. Though the flight combat simulator game, even in the first result, where the plane model was really well done, the environment model was well done, there was terrain, height to the ground, there was even water, the clouds looked good, everything here was really well done from an actual like 3D model standpoint. And something else I will say is its visual capabilities seemed quite good as well, where it replicated this website just from a source image that was created as a mock-up with Gemini. Its creativity and storytelling is, of course, it's there. And overall, I think this model really punches above its weight class just in terms of its ability basically to do like web stuff. As we saw, if I leave it in the video, unfortunately, the Python test with OpenCode just didn't really work very well. I had tried C++ with it, and it was just kind of disastrous through OpenCode to the point where it didn't even make its way into the video. So I don't know specifically how well its abilities will translate over into different languages, but that is, of course, something folks will try depending on the use case they have that would necessitate that. For closing thoughts, this really is a strong model, and because of its relatively lightweight in terms of actually being able to be run on a wide variety of kind of hobbyist, enthusiast level hardware, I would go out on a limb and say this is probably one of the finest local models for folks to be able to run when factoring in whether or not it's realistically able to be run on a lot of hardware. And this model absolutely 100% is, which I think makes it pretty special. And I've been seeing still to this day a lot of cool, impressive results that folks have been sharing that this model has made. And it's exciting to see a local model with such stark capabilities that is not really too big in terms of what it takes to actually run it. So that is going to conclude our first look and test of Qwen3.6 35B-A3B being run locally, and it's very impressive. I am excited to see other Qwen 3.6 open weight models, especially the 122B. That's very exciting. Hopefully we will see that sooner than later. Thanks for watching.